For number, I can't do that. Oh, there we go. For number 10, what are the shapes that we're dealing with? We got an outside shape, we got an inside shape. What are the shapes? Here's cylinders. We have an outside cylinder. That's the insulation for the inside cylinder, which is the watt hotter heater. Oh man, I'm really good at life today. So we have a hot water heater and then the insulation on the outside. So you can see that the inside, the hot water heater, it's got a radius of 13 inches, and then the insulation is 3 inches wide. So what's the overall radius for the whole shape? 16 inches. Okay. So I'm gonna do outside minus inside. Does that make sense? Outside minus inside. Okay. So I'm gonna write my outside. I'm going to write my base and I'm going to write my volume, just like I normally do. And for the base, I'm going to do, it's a circle, right? Because it's the area of the base, which is a circle because it's a cylinder. So base, and then we said the radius was 16. So base times 16 squared is what? 256 pi. And then, what's the height of the cylinder for both the outside and the inside? 75. So then I'm going to say area of the base 256 pi times the height is going to be what for the volume? $19,200 pi, and this is inches cubed. Okay, so there's the outside, and then for the inside, I'm going to have the base, and I'm going to have the volume. And the base for this one is only going to be the 13 inches. So we're going to say pi times 13 squared is 169 pi. And then we're going to say area of the base times the height. And then what's the volume? Okay. So then, how do we figure out how much is needed to create the sleeve? Okay, so outside minus inside is going to be 19,200 pi minus 12,675 pi. Now these units are inches cubed, so these are not the units that they wanted, but they're still the units that we've got, so we're going to go ahead and just do the answer this way to start with. So I've got, in terms of pi, what do I have? $6,525 pi inches cubed. Okay. Now let's Google, real quick, let's Google how to convert cubic inches into cubic feet. Okay. So real quick, I'm going to Google how to convert cubic inches to cubic feet. Give us a formula. Divide the total by 1,728. There's 1,728 cubic inches in a cubic foot. We see that? Is that what you got, Court? So it looks like this is the decimal of that. I bet if we did 1 over, let me just double check this, 1 over 1,728, it's probably that same decimal point, 0.00578,704. Yep. Here, let me show you what I just did. I just double checked to see what 1 divided by 1,728 is. And it's that same decimal that was on here, this conversion that they put right up here. So that's the conversion if you didn't want to do the math yourself. So what we're going to do is we're going to take the answer that we had. We're going to do 6,525 pi. We're going to divide it by 1,728. And then that is the number for our cubic feet. Now they said to do the nearest tenth. So we're going to do 1 decimal place, 11.9 feet cubed. Okay. If I was going to put this on a test for you guys, I would give you the conversion. So the answer is C. So we were able to get almost all the way there, and then we just had to use Google a smidge. Okay. Any other problem that gave you trouble? Now, what I did with this problem before, I can almost guarantee, is I just used Google and I just did the conversion thing on Google as opposed to doing the math to get it. I just said, hey Google, what is the conversion? Tell me the answer, and then I was done. Okay, are we comfortable with that assignment? We're good? So the two things that we're turning in are cross sections and composite volumes. We're putting 2 assignments in the center of the tables. We got them? 2 assignments, yes. We don't have to collect them right now. We'll give people time, but then yes, absolutely, you can collect them in a little bit. Okay, so cross sections, composite figures, that's what we're adding to the table. Now, we're going to go ahead and finish up our notes. So we got one more example problem to do, I believe. Where are my notes? That's not it. Oh, here. Okay, so it says, at work, Kevin is designing a prototype. That one, right? That's one we haven't done example 4. Okay. So I'm going to do that on my notebook paper also. So it says, at work, Kevin is designing a product prototype. This is example 4 of the notes. Part of the product is a cylinder. Yes. Make sure you get the example written down and then you can go to the bathroom. Is a cylinder with a volume of 108 pi cubic inches and a radius of 3 inches. So the volume is 108 pi. You don't have to write this down unless, because if you have the notes, you might just circle these numbers. I'm writing it down because I do not have the problem typed up for me, but if you guys have the problem typed up, then you could just circle these numbers. So the volume is 108 pi cubic inches. The radius is 3 inches. I'm just reading straight off the page. When he presented the prototype to the company, they decided that the cylinder should have been a volume of 171 pi. So that is what it was. They wanted it to be different. wanted the volume to be 171 pi cubic inches. Instead, based on this information, how much height will he need to add to the original cylinder? So if he's adding height, it looks like they're cool with the radius. They wanted the radius to continue to be 3 inches, but they want the height of the cylinder to change to make that volume increase. All right. So what we're going to do is we're going to start with a cylinder with these measurements. This volume, this radius, we're going to see what the height is for these measurements. And then we're going to see what the height would be for this measurement. And then we're going to see how much increase that would take. Okay? So let's go ahead and start off with what we've got for a cylinder. For a cylinder, we would say, all right, the area of the base is pi times what? R squared, so pi times 3 squared. So we've got the cylinder, we've got the old version and the new version, and both of those have a radius of 3. So I'm going to say the base for both of those is pi times 3 squared. So both of those have a base of 9 pi. Okay. And then to find the volume for both of those, we're going to say the area of the base times the height, which we don't know. All right, so there's our volume formula for both of those, and then we actually know the answer. This equals 108 pi for the old one. It equals 171 pi for the new one. Okay, are we comfortable with this so far? Okay, so what we're going to do is we're just going to be solving for the old height, solving for the new height, and comparing the answers. We just want to see what the height increase was from the old prototype to the new prototype. So here we have 9 pi h equals 108 pi. Here we have 9 pi h equals 171 pi. And on both of these, the first thing I'm going to do is I'm just going to get rid of the pi's to make this easier to solve. So just get rid of the pi's because we have one on each side. So I've got 9h equals 108, 9h equals 171. So for each of these, what do we need to do? Divide by 9. So this h is 12, and this h is 17, and so how much did they add? 5 inches. Oh. My ears are broken too! Okay. I have a headache right now. So no. It's very sad.
Did your headache stop when you were in pain?
My foot hurts right now. So yes, they both hurt. Okay. They added 7 inches to the height. They added 7 inches to the height. Ta-da! So be careful on these ones because the two answers we got were 12 and 19, but the multiple choice answer we're going with is 7. So that could be an easy distractor thing where 12 or 19 could be multiple choice answers, but you're not choosing them. All right. So today we have some problems to do. Ta-da! Are you guys ready? You ready to do them? Some of them are easier than others. Some of them are like, you're going to look at it, you're going to be like, this is literally just the volume. Just find the volume of something, and you wrote it in a word problem and called it a story. Yep, you're good. And then some of them are a figure problem. So some of them are going to seem like, oh, we've done this before. And then some of them are going to seem like, yeah, this is a little bit more complicated. So, do you guys want to flip through and maybe find if there's one that looks scary? Oh, there's a door problem. There's a door.
That's such a nice stapler.
I love that stapler. Yes. I already printed all the printings. I'm so sorry. Do you have a Chromebook? Yeah, get your Chromebook out. Okay. Because that's where because it's on Canvas. Silly. Okay. Okay. So let's go ahead and do number 16. Okay. It says a mug can hold 26.7 ounces of coffee without overflowing. It says the radius of the mug is 5 centimeters. And 1 cubic centimeter equals approximately 0.034 ounces. So we have two things going on. We have the mug being measured by fluid ounces, right? How much coffee it can hold liquid-wise. And then we also have the mug being measured by its like volume, like as in not fluid. So it's being measured two different ways. So over here, let's say the fluid. So that is, the volume is 26.7 ounces, which is cool, but we haven't learned anything about how to measure, these with fluid. And then it says 1 cubic centimeter is 0.034 ounces, which is good to know. Okay. So what shape is a mug? A cylinder. Okay. It's a cylinder. What shape is a mug? It's a cylinder. Okay. So for a cylinder, we're going to do area of the base. We're going to find the volume after that. So the area of the base is pi times what? R squared. What's the radius? 5. Okay. So what do we need next? 25 pi, okay? So now the area of the base, 25 pi times the height equals the total volume, right? And they told us the total volume is 26.7 ounces, but this measurement is in terms of centimeters and this measurement is in terms of ounces. Do you guys see how that's a problem? We have two different units of measurement, okay? So what we got to do is we got to take our ounces measurement and we got to convert it into centimeters. Does that make sense? You want to convert it into centimeters. So what we're going to do is we're going to take the volume, the 26.7 ounces, and we're going to divide it by 0.034 ounces. Okay? And we're going to see how many centimeters that is. Do you guys still do the like railroad track thing in one of your science classes? To convert your units? So this would be like you are converting this to do your units. Here's your railroad tracks. This is how I did it in high school. We would do 0.034 ounces is the same as 1 cubic centimeter. And so the ounces and the ounces are going to cancel out. Does that make sense? And so we're going to do 26.7 divided by 0.034. And the new units are going to be cubic centimeters. Yeah, does that make sense? That's what we're doing if you have done this in one of your science classes to convert units, okay? The railroad track thing. That's how we convert units. If any of you guys have done that in your science classes. No unit conversions in your science classes. So what science class do you do that in? Chemistry? Are people who are not nodding with me, or you guys have not taken chemistry yet? There you go. Okay, so here's how we convert units. So one centimeter cubed is the same as this. So it's kind of like I'm taking this number and I'm multiplying it by 1, right? So it's the same thing over the same thing. They're two different numbers, but they represent the same thing. So it's like I'm taking this and I'm multiplying it by 1. So I'm changing what it looks like, but I'm not changing what it equals, okay? And so 1 cubic centimeter is the same as 0.034 ounces. Then I'm kind of working this like a division problem. Ounces divided by ounces, well, they cancel each other out because I have an ounce on top and an ounce on bottom. Does that make sense? And I've introduced a new unit that is centimeters cubed. So centimeters cubed is my new units. Now I'm doing 26.7 multiplied by 1. So that number is not going to change. And I'm going to do 26.7 multiplied by 1 and divide it by 0.034. Does that make sense? That's kind of how unit conversion works. What? Science and math kind of going together? Yes. So 26.7 divided by 0.034 is 785.294. We're going to leave this whole thing in our calculator because this is going to be beneficial. So it is 785.294. That is the whole volume. Okay? That is the whole volume in terms of centimeters cubed. Okay? So I'm going to take this over here and I'm going to write equals 785.294 centimeters cubed. Okay? Now, how do I take this? So I've got 25 pi h equals 785.294 centimeters cubed. How do I take this and solve it for h? Divide by 25 pi, divide by all of it. Yeah. So I'm going to say I want to do this as a fraction button because I want to divide not just by 25 but also by the pi. So what I'm going to do is I'm going to hit alpha y equals alpha y equals, because I want the whole thing. And on the top, I'm going to take this, I'm going to highlight this, and press enter. I want that on the top. Yeah, you can do second A and S, and it will pull that. And then 25 pi. So I want everyone to try it to make sure you can do this accurately, because I just did a tricky little math magic. Calculator magic, actually. I did some calculator magic there. Math magic. So we want to make sure everyone can do 26.7 divided by 0.034 and get this decimal. And then make sure we can get the decimal on top and the 25 pi on the bottom. Okay. Because I'm going to show you guys what the common wrong answer is. Okay. So everyone see what just popped up on my screen, what the answer is? Okay, so what multiple choice answer is the one we got? 10. 10 is our answer. Now, the common wrong answer for this is 785.294 divided by 25 pi. This is the common wrong answer, okay? See how different that is? It multiplied by pi instead of dividing by pi. It divided by 25 and then it multiplied by pi. You guys see that? Okay. So the reason that I plugged it in as a fraction like this is because you can divide by 25 and the pi at the same time. Whereas if you type it in like this, it's going to divide by the 25 and then multiply by the pi, and a lot of students don't realize that's what's happening. Okay? Does that make sense? Yes, Lucas. Then when you divide by 25 pi, you put the 25 pi in parentheses, and it will do it correctly. So 785.294 divided by 25 pi in parentheses gets you the correct answer. You just have to be careful. Okay? All right. We got that one. Now, we were not doing that one because it was easy. We were doing that one because it was difficult. So don't think that all the problems on the page are going to be like that one. Okay? We chose that one on purpose. All right, you guys good? Good? Okay. Let me go ahead and put some music on, and then I'll get the answer key in the back for you. Yes.